Hello, everyone. Welcome back to new Vuitton Podcast, episode number 3. Today, we are having very special guest who studies DMT class in De Anza College. He went to Applied Physics and Material Science in UC Davis and works at Atlas Copco. And his name is Tak.
I'm also not that special. I barely graduated because physics is extremely hard.
How was your physics degree?
I mean, it was fun. I enjoyed physics when I was in community college and high school. But once I got to UC Davis, it's once you get to UC systems, it's just, I don't know. It's extremely hard. It's extremely theoretical, and it turns out that I'm more of a hands-eye application kind of guy.
How many calculus class have you taken in UC Davis or community college?
I mean, I've taken the entire series at community college. I've taken up to linear algebra. Then once you get to Davis, you take, or if you're in the physics department, you take physics math, which it is advanced math, and if you probably take the same classes as you do when you're a math degree, but it's more tailored to physics.
So how does the chain rule of derivatives apply to complex physical systems, such as electronic circuits?
Well, chain rule is just a fancy name. It's not really like a big concept. Chain rule is just called a chain rule because it keeps chaining down derivatives. It's the simplest way that math can describe a dimensional change, which is derivatives too. But it's just a fancy way of getting to the next higher dimension, and that's it. It's nothing. It doesn't really do anything to the physical world. It doesn't really do anything to electrons or whatever. It's just a way that people have discovered to go above and beyond what dimension you're currently in, or your mathematical dimension as well. The fact that so you know how in homework and stuff, chain rule, they give you a sample problem, or they give you a problem. The fact that that problem exists means it's a proof that higher dimensions exist, because if higher dimensions don't exist, you can't use chain rule to solve it.
Chain rule. I see.
The most influential class I took was dimensional analysis.
How was it?
Yeah, so dimensional analysis, it's not about numbers. It's more about units. And when you look at F equals MA, right, the simplest thing is that M is just a constant, right? And A is a variable. And there's things that there are units that are unitless. There are variables that are unitless, meaning in dimensional analysis, it doesn't mean anything. And acceleration is a dimension. F also has a dimension. But when you get to more complicated systems, you get dimensionless variables that just don't really give you much information. So if you get really good at dimensional analysis, you can probably look at any equation and be like, oh, I know what that means. And also I know basically what the answer should be.
So also can understand how this equation would look like in graph, or
Yeah. Well, I don't know about graph, but any equation, right? You have an input and an output, and that input, whatever you put in, if you know what that unit is, you can kind of guess what the answer is going to be.
That's interesting. Yeah. Can you share challenging problems you encounter in your work require like deep understanding of derivatives and chain rules to solve?
I don't do that kind of work. You need to go talk to a researcher or something like that, because most of the time you don't use calculus. Most of the time you don't do that kind of stuff in work. You get paid to do Excel sheets and PowerPoints.
Okay.
And it's like the most I've used calculus is in like SolidWorks. But that's just a hobby.
Hobby.
Yeah, you really don't use. I mean, like, do you use calculus?
No.
Yeah. I mean, the most useful thing I used for calculus was like how to determine my acceleration when I'm driving. Like that's and I guess if you're doing like 3D modeling or geometry, it's good to know how to revolve around an axis or how to manipulate graphs to make whatever shape you like. Do a lot of things that we have every day. But then again, it's like prove it, right? Like what do you use calculus for? I don't. No one does. Like, is it practical? Probably not. But again, it's so powerful that you can get across dimensions, which is why everyone teaches it.
So interesting. Yeah, thanks for joining me today, Tak.
Yeah, no problem.
Today's episode is coming to an end.
Please stay tuned for next episode. Thank you, everyone.